Did you know that across rain-fed agricultural systems, yield gaps often exceed 1 to 5 tons per hectare? This means that we need better data-driven decisions that can unlock tons of productions per hectare. As a solution, we built Field Edge FL, a lightweight federated learning framework that is delivered in form of a low-cost farm kit with low-cost hardware that reads on-farm sensors and turns this soil data into clear crop recommendation. It works even when the connectivity is limited, and it is very light by design and is tailored to each field. This is the overview of our project. Let's see how it works.
Here is our prototype. It consists of a MacBook PC, 24 GB of RAM that acts as our edge server. Then we have a Raspberry Pi 4, which is our client, one of our clients, and this is another Raspberry Pi 4 that is part of our client. And then, after the server has initiated the training continues in the clients after reading the IP address of the client is when the client starts training. And this is how the server shows that is connected to certain devices, and then how each user is training until the number of training rounds that are already predefined are reached is when the training stops. And for our test data, we have a 7-in-1 sensor, and this just shows the accuracy metrics, precision.
So this is our SMS output, our dashboard output, and then the core technological innovation is the lightweight federated learning framework for crop recommendation, which is equivalent to 2 bags of fertilizer, but continuous training and knowledge. Thank you.
Now to the questions. Amaji, do you want to go? And then Julia?
Yes, so thank you for your submission. I like the idea that you're using federated learning, but I see a plethora of challenges ahead in turning this into something real that can be used. Number one, you're solving crop recommendation. The average African farmer is not confused about what to plant. They're already planting on their hectares. They are more concerned about how to improve the productivity of the planting. So you're solving a problem that doesn't even exist. They have already decided I'm planting cassava. All I want to know is, how am I going to make sure that I get maximum productivity from this land? That's number one. The federated machine learning approach is amazing, but for this to work, you have to have so much sensors covering all the land for the thing you get back to actually be useful. So I think this is one of those ones that it's a great idea, but requires a lot more thinking to actually build something that will actually impact African farmers. So it's not a question, it's more of a comment.
Can I respond to the comment? Yeah, so we understand, it really needs a lot of sensors to work. So that was the idea, because we're collecting, maybe even per farm, because we have variability even in the farm, spatial variability as well as temporal variability, right? So in a farm, let's say a 1 acre farm, you put, so far what we have tested is like, we have like 3 sensors. The management zone is defined from the data that we have from remote sensing data. So it determines how we are going to manage the farms, or how many sensors are needed in a farm. So we have the data, and then because we put these sensors in the farm, it means that we are collecting data and we are training continuously. So the issue that you say that we'll need so many sensors, yes, but when you have sensors already in one farm, you can use that to train other farms. So yes, and the question of crop recommendation, yeah, because our sensors get the parameters like how much nitrogen fertilizer you need, how much phosphorus, how much is potassium is in the soil. So with that, it means that, okay, the question of not the crop per se, but also you can inform the farmers like what to use or what input to do in a given situation. So yeah.
Okay, Lamek, do you want to go with your question? And then back to you.
Yeah, I really like this project. It's a nice one. However, my challenge also with federated learning, how do you aggregate the data to ensure that it's still tailored to my farm, because we are getting data from different farms and then you aggregate them to train this general model. And how will you then still from there aggregate the data to make sure that that same model will work for me who is planting maize and somebody who is planting, for example, rooibos tea, for example? How do you make it work for everyone and still specialize for every farmer?
So we have a selected crops so far. We're not doing for every crop. So we have selected crops, and then we have the values that are needed for such crops. It's not for every type of crop. So yeah.
And then also in terms of giving me, I need nitrogen, I need phosphorus. I spend a lot of time in the garden, and I also have a family farm in Nigeria. $5 from Amazon soil testing kits will tell me what is happening in my soil. What do I need? Whether I'm depleted in NPK, it will give me the acidity and all that. So I can still solve that with something very, very cheap. And so this idea that you have is a very powerful idea, but you need to really iterate upon it because it can really do a lot for us. And then also finally in Africa, getting fertilizer from abroad or even fertilizer locally is very, very expensive and adds to the cost of farming. So if you can work on something that can actually use something that is local, like local composting, to drive down the cost for the farmers, that would really, really, really be useful. Thank you.
Okay. Can I also respond to that? So when we
Yes,
were
please.
when we were thinking about this project, it is in Tanzania. The way our the way our Ministry of Agriculture works and the way the fertilizer is being procured for farmers is that it is government controlled. So that's why we had this idea. So yeah, that's the case.
Okay, thank you.